Today we're reviewing derivatives, okay? As you can see, there's only about 13 pages of review because I'm hitting some of the main points with derivatives. And then in between some of the main points are going to be some examples pulled from old IB exams, straight from old IB exams of where this stuff can come into play when it comes to derivatives. One of the things that you need to make sure that you remember about derivatives is that there's two different types of rate of change. Anytime you hear rate of change, it usually is associated with derivatives, okay? But you have average rate of change, and then you have instantaneous rate of change. When we first talked about derivatives at the beginning of the year, average rate of change is essentially you finding the slope of a line. That is old school slope, okay? So average rate of change is old school slope. And we find that by doing y2 minus y1 over x2 minus x1. What did that mean in context of a calculus type of problem? What that essentially means is that you're essentially finding the slope of a secant line. But the way that calculus came into play is that as you continue to move that point closer and closer to like the first point, then you went from it being average rate of change to instantaneous rate of change, in which essentially the distance between those 2 points is non-existent, and it forms a tangent line, okay? Instantaneous rate of change is the slope of your tangent line, okay? AKA the derivative, all right? So anytime if a question asks you what is the rate of change of a particular object or anything like that, it is essentially asking you to find the slope of the tangent line. How do you find the slope of the tangent line? By taking the derivative of the function and evaluating the derivative at a particular point. That's what instantaneous rate of change is. It is slope of the tangent line, derivative, evaluated at a particular point. So how did we find the derivative? We started it out by the formal definition. We spent an entire day doing the formal definition. This is how you went about figuring out a general rule to find the slope of a tangent line for any function, okay? It was the limit as h approaches 0 of your function evaluated to x plus h minus your function all over h. Now, if I recall, I remember you guys having some difficulty with this. And so we're going to do an example together. Now, is IB going to ask you to use the formal definition over the rules of derivatives that you guys learned about? To be honest, it could go both ways. Okay, so it's good to know how to use the formal definition in case you have to show that the derivative is what it is, or if it asks you to use the first principles or anything like that. Okay, so let's take a very simple function. Let's say your function is 2x squared minus 3, and you were asked to show what the derivative was using the formal definition. Okay, you would apply this formula right here. It's the limit as h approaches 0 of f of x plus h. Remember, anytime you see this, that means you're plugging in x plus h into every x in your function. So then that becomes 2x plus h squared minus 3. That part that I've written in the blue represents f of x plus h. Then you had to do minus f of x. That means that I'm going to subtract my function, which is f of x. Yes, we put that in parentheses because that minus, what am I going to have to do with it? Distribute it. Then all of this will be over h. This is how you take the formal definition and apply the different properties, or not the different properties, or different pieces of the formal definition. Once we apply the formal definition, now it's just a matter of simplifying. The one thing that you want to make sure that you do is as you simplify in each line, you want to make sure you keep bringing down the limit as h approaches 0. Because when we originally talked about limits and evaluating, at some point, we're going to plug 0 in for h. If I were to do it now, at this point, I would get 0 over 0. And we do not want 0 over 0. So we have to continue to simplify until we get to the point that when we plug in 0 for h, we don't get 0 over 0. So let's simplify this. X plus h squared, what am I going to have to do with that? FOIL, okay? So x plus h times x plus h ends up being x times x, x times h times x. So xh and xh make how many? And h times h? Then I bring everything else down. I have a -3. Then I'm going to distribute that pink negative to that parenthesis. That's a negative 2x squared plus 3. All of that is over h. What should I do from here?
Distribute the 2.
Distribute that 2. Because again, I want to get to a point that when I plug in 0 for h, I don't have 0 over 0. If I plug in 0 here for h, I'm going to get 2x squared minus 3 minus 2x plus 3 over 0. All that's still going to be 0 over 0. I don't want it yet. Distribute over that 2. That gives me 2x squared plus 4xh plus 2h squared minus 3 minus 2x plus 3. Again, the formal definition is how we can show that the derivative is going to be what it's going to end up being. So I want to make sure I don't leave out any steps. Once I distribute, what do you see?
Some terms cancel out, so it'll be 4xh plus 2h squared.
Very
Okay.
good. Over h, yep. Because that 2x squares cancel out, the 3's cancel out, and really and truly, when you use the formal definition, all of your non-h terms should cancel out. So all our terms that didn't have an h involved, all canceled out, and they should. If they don't, you didn't do something right. So if I'm only left with h terms in that numerator, don't both of those terms have an h in common?
You can factor it out.
So I want to factor it out. And this is going to be the only way that I'm going to be able to cancel out an h, because I have to factor it out. I don't take it out from each term. I factor it out, then I cancel. So now I'm left with the limit. I'm hoping you guys put the limit as h approaches 0 for every line of 4x plus 2h. At this point, I'm able to evaluate h at 0. Because when I plug in 0 for h, I will not get 0 over 0. I would get what? 4x. And 4x is the derivative of 2x squared minus 3. This is just how we use formal definition to get the derivative. Remember, the derivative is a general rule to help us find the slope of a tangent line at any point. At any point. After we went over the formal definition, I taught you the different rules of how to find the derivative, which was essentially like a shortcut to get from 2x squared minus 3 to just 4x. Okay, that involved your power rule, which was this one here. And then there were a few other rules that went along with this. You have written this down before. I literally pulled this from your old notes. Okay, if I'm given a power function, AKA a number or a variable raised to an exponent, then the derivative is found by bringing the coefficient, the exponent down to the coefficient and subtracting 1 from the exponent. So x squared would turn into 2x to the 2 minus 1, or in other words, 2x. The constant basically said that if you had a number and you were asked to take the derivative of it, well, the derivative of a number is 0, or the derivative of a constant is always 0. If you have a coefficient or a constant in front of a function such as 2x squared, like that last problem that we did using the formal definition, you essentially are taking the derivative of the function and then multiplying it by the coefficient. So if the derivative of x squared is 2x, and there's a 2 in front, I just do 2 times 2x. That's how we were able to get 4x as the derivative of that function. Is it coming back to you guys? And then if you have multiple terms that make up one function, you just take the derivative of each piece. For example, the equation of the curve is y equals negative x squared plus 8x minus 12. A section of the curve is shown from the diagram below, which I took out because I'm trying to build up to these different pieces. Find dy dx. What does this notation mean? It means the derivative. It was one of the ways to represent derivative besides the prime notation. You could represent it using dy dx. And so to find the derivative of y, I'm essentially taking the derivative of each term. What's the derivative of negative x squared? What's the derivative of 8x? Positive 8. And what's the derivative of negative 12? 0, because negative 12 is a constant. The derivative of constant is 0. So dy dx would be negative 2x plus 8. Here's one. I believe I pulled this from 2017's exam. It says function f is given by f of x equals 4x to the third plus 3 over x squared minus 3. You have to write down the derivative. Now, before I can actually write down the derivative of this problem, I'm probably going to need to do something to this term. Exactly. The power rule only works if it's a power, if it's a variable raised to an exponent, not in a denominator. So anytime you saw something like this, you needed to make it negative to bring it up from the denominator. Right? That's your laws of exponents. And then from this point, you're able to find the derivative. Find the derivative using the rules. What is the derivative of this function? Very good. Because when you bring this down, this becomes 3 times negative 2, which is a negative 6. You subtract 1, which gives you a negative 3, but then you have to make it positive, so you bring it down to the denominator. Of course, 3 times 4 is 12, subtract 1, and that's how you get 2. Very good. So that would be your derivative. You want to work with your positive exponents. Why? Because if you have to do anything outside of just taking the derivative, like you have to do in part B, then you want to make sure that you do, you're only working with positive exponents. It makes things easier. It says the point on the graph of f at which the gradient of the tangent is equal to 6. So you have to find the point on the graph of f at which the gradient of the tangent is equal to 6. Gradient of the tangent means what? It means the derivative. Anytime you see those words together, that means the derivative is equal to 6. That's exactly what you do in order to determine what the point is. You set the derivative equal to 6 and you solve from there, okay? This is how you would do part B, but you got to be able to understand that when it says the gradient of the tangent is equal to 6, that means you have to set the derivative equal to 6. You can do this a few ways. You can go into your calculator, y1 for the left side, y2 for the right side, see where they intersect. Or you could try to solve it algebraically, your choice. But find my x coordinate, because that's essentially what you'll be finding when you do this. You're finding your x coordinate. So we graph 6 into y1, 12x squared minus 6, x to the third, y1, y2, we look at where they intersect. So then that's going to be second trace, option 5. Move closer to that intersection point and click enter 3 times. Did you guys get x equals 1? Very good. So if x is equal to 1, it's asking me for the point, which means I need an x and a. How do I find the y?
You plug that back into the original?
Very good, because I'm looking for the point on F. So yes, I plug it back into the original. So that becomes 4 times 1 to the third plus 3 over 1 squared minus 3. 1 to the third is 1. 1 times 4 is 4 plus 3 over 1 squared, which is 3 minus 3. So what's my y coordinate?
4.
So my point, my answer is going to be 1, 4. Questions?
No, ma'am.
Remember, gradient of the tangent means derivative. You would have to set it equal to 6 here. When you actually plug in a value for x into the derivative, you're finding the slope of the tangent line at that particular point, okay? I want you guys to do the same thing here. I've thrown in a little bit of old school review as well, because I mean, hey, that's what these problems do. They just don't assess you on just straight calculus. They're going to incorporate other things, okay? So I want you guys to take a few minutes and do this one. I want you to find the exact values of each of the zeros of f. I want you to expand this expression, and then I want you to find f prime of x. Since our function is 2x plus 2 times 5 minus x squared, and we're asked to find the exact value of each of the zeros of f, what do zeros mean? There's another word for zeros.
The x-intercepts.
Exactly. So it's asking me to find the x-intercepts of this function. Now we know how to find the x-intercepts algebraically, yes? How do I find the x-intercept of any function?
You set them equal to 0.
Set each of your factors equal to 0. That's how you find the exact value. Remember that word. It even says it on the front page of every test. It says, leave answers exact or correct to 3 significant figures. Exact means no decimals, simplify fractions, radicals, things like that. So in order to find your exact value, you were going to have to take each of your x or each of your factors and set them equal to 0 and solve algebraically to find the exact value. You plugged it into your calculator and did it that way, you might have ended up with a decimal and that would have not been correct. So subtract over 2, divide by 2, x was equal to here. I'm going to add over x squared, make it easier. How do I get rid of the squared?
Square root it.
And you need to remember, when you take the square root,
So x is -1, sorry.
yeah,
Plus or minus.
you got to remember the plus or minus. So x is plus or minus the square root of 5. Not just positive square root of 5, but also negative. Okay, so you should have had 3 x-intercepts. All right, and these will be the exact value. If you put the decimal equivalent of the square root of 5, it would have been incorrect because it asked you for the exact value. Okay, so you got to remember, set your zeros, set your function equal to 0 to find your x-intercepts. Expand the expression of f of x. What does expand mean? Foil, essentially, okay? So to foil that, that's easy. First, outer, inner, last. What you guys get for your function?
10x minus 4x squared. Oh, wait.
All right, 6x or 10x, wait a minute.
Well, I think I combined my terms.
Okay. So how about this? What was our final answer after we combined like terms and everything?
Oh, wait, never mind.
I can say it.
I got 10x minus 4x cubed plus 10 minus 2x squared.
So you said 10x, say it again, I'm sorry.
It'll be a plus 10 after that, and then a negative 2x squared.
Do I have it right?
I got that, except negative 2x cubed instead of 4x.
Okay. Yep, so
Yeah, that makes sense. Yeah.
all right, that's how we get the 10x. That's how we get the negative 2x to the third, the positive 10, and then the negative 2x squared. Very good. So this would be bi. This is expanding it. So then the derivative of this, what's the derivative of 10x? 10. What's the derivative of negative 2x to the third? What's the derivative of positive 10? And what's the derivative of negative 2x to the second? And of course, you can always put this in order. So negative 6x squared minus 4x plus 10, same answer. Very good. Questions on finding the derivatives? After you guys learned how to find the derivative, you guys learned how to write the equations of the tangent line and the normal line. Again, this is pulled straight from your notes. The one thing that you need to remember is that the tangent line equation, this is essentially the format. If you don't remember the format, just remember how to write the equation of the line. Y equals mx plus b, okay? This f prime of a represents the slope or the gradient of your tangent line. And then a and f of a represented the coordinates, represented the point that you would need to write your line, okay? So as long as you have a gradient, as long as you have a point, you can write the equation of your tangent line or your normal line. Remember, normal is perpendicular to the tangent. That's why the gradient here in the formula is flipped and the sign is different. Because remember, perpendicular lines, their slopes are opposite reciprocals of each other. So if the slope of the tangent line was 3, what would be the slope of the normal line? Negative 1/3. Unfortunately, you can't get straight to the normal slope. You have to find the tangent first, and then you can do the opposite reciprocal to get the normal. So we're going to do some practice with this. How many do I have? Only got one of these. All right, we'll do this one together. It says consider the function g of x equals x to the third plus kx squared minus 15x plus 5. It says find g prime of x. That's pretty straightforward. What is the derivative of x to the third? What about kx squared? 2kx. Remember, anytime they throw in an additional variable that's not x, okay, that is essentially represents some constant. So you treat it just like you would if it were like a 2 in front or like a 3 in front, okay? You just multiply the exponent by the coefficient. What's the derivative of negative 15x? And of course, we know the derivative of 5 is just 0. So now that I have my derivative, it says the tangent to the graph of y equals g of x at x equals 2 is parallel to the line y equals 21x plus 7. A lot of words there. Let's break it down. The tangent to the graph, what does that mean? It means the derivative. At x is equal to 2 is parallel to the line. Parallel lines have what slopes? So what's the slope of this line? 21. So this is essentially saying the derivative when x is equal to 2 is or has a slope of 21. So that means the derivative, which I know already, when x is equal to 2, so I can plug in 2 for x, is going to equal 21. So I can set it up in that fashion. The derivative, So for BI, to show that K is equal to 6, the derivative when X is 2 is equal to 21. And that's exactly how we would set it up to show that K is going to be 6. So again, tangent to the graph. The wording from that other problem. Gradient of the tangent. They all mean derivative, okay? 2 squared is what? Times 3? 2 times 2 is? It's a show problem, so you want to show all your steps to make sure you don't lose any marks. Methods. What's 12 minus 15? How do I solve for K? And then, so this is exactly how K is going to be equal to 6. So now it says find the equation of the tangent to the graph of y equals g of x at x equals 2. Give your answer in the form of y equals mx plus c. So that's the form we have to write it in. The equation of the tangent line. All I need is a gradient and all I need is a point. Well, what is my gradient?
21.
21. Now I need a point. Well, I already know my x coordinate is 2. How do I find my y coordinate? I have to plug it into the original, and I know that K is equal to what? 6. So that becomes 2 to the third plus 6 times 2 squared minus 15 times 2 plus 5. Can y'all find my y coordinate, please? So my y coordinate is 7. So now using my equation to find the equation of the tangent line, okay, A essentially represents the point 2, okay? So I have my slope, which is 21, x minus my x value of my point 2 plus 7. Of course, that's not in that form, but all I need to do is distribute and combine like terms. 35?
Yeah.
There we go. Increasing, decreasing in stationary points. So I expect you to write this down? Of course not. I just wanted to find one picture that kind of represents everything that I need to say when it comes to increasing, decreasing in stationary points. You always know when a function is increasing if the derivative is greater than 0. That means when you find the derivative and you plug in an x value, if that answer is positive, that means the slope of the tangent line is positive, which means the graph is going up. However, if the derivative is less than 0, aka the slope of the tangent line is negative, that means the graph is going down. If it's equal to 0, that means there is a stationary point, okay? Either a maximum or a minimum. How do you know if you have a maximum or a minimum? Well, if I go from increasing to 0 to decreasing, that means I have a what? I have a maximum, and you can see it right here. I go from increasing to 0 to decreasing. So I have a maximum at that point A. But if I go from decreasing to 0 to increasing, what do I have? I have a minimum. So I have a minimum at B. Again, if I go from increasing to decreasing, I have a maximum. So the important things to pull from here, what are circled in brown? When the derivative is greater than 0, I'm increasing. When the derivative is less than 0, I'm decreasing. When the derivative is equal to 0, I have a stationary point, a turning point, a maximum, a minimum. It's a max if I go from positive to negative. It's a minimum if I go from negative to positive. How'd you find the derivative? You wrote it down. What was the derivative of this function from the previous question?
-6x squared
was the derivative. So when it says use your answer to part B double I, which is this is what it was, to find the values of X for which is increasing. In order for me to determine where it's increasing, I need to find the derivative. And on top of that, I need to actually find out where the derivative is equal to 0. Because if I can figure out where those stationary points are, then I'm able to use a number line to test to see where it's increasing or decreasing. Okay, so you want to take the derivative and you want to set it equal to 0. Okay, now from here you can do this through factoring. You can plug it into your calculator and see where they intersect. How do you want to do this? Doesn't matter to me. All right, so I go into my calculator. In Y1, I need to type in my function, or 0, really doesn't matter. Y2, I need to type in the other side, which is 0. I want to see where these two intersect. Easily see that. That's where they intersect. So I have two X values. Now, granted, when the derivative is equal to 0, that's where I have a stationary point. Specifically, I'm looking for where it's increasing. Okay. So let's find these stationary points. Find the intersection. I have two of them, so I have to do this twice. I move closer to the left one, click enter 3 times. What's negative 1.66666666? What is that? I hate decimals. Huh?
Looks irrational.
It's actually rational. That's negative 1 and 6666666.
5, negative 5/3.
Yep. So X is equal to negative 5/3. Now, of course, you can use the decimal equivalent. There's nothing wrong with that. I just know y'all in your rounding points, that's always an issue. Okay, let's find the other one. One.
Yes.
Okay. Now, from here, you can make a number line and you can pick test points in between to find out where the graph is positive. That's where it's increasing. But this represents the derivative. This graph right here represents the derivative. When the derivative is positive, that means the graph is what?
Increasing, so it's just gonna be the left side of your maximum, right?
It's not the left side of your maximum. Like if this right here, this picture on our graph represents our derivative. Wherever the derivative is above 0, that means that's where it's positive. So that means in between negative 5/3 and 1, that's where it's positive. That means that's where the graph of the original function is increasing. Okay? So we either look at the graph and see that, oh, well, wherever the graph is above the x-axis, that means that's where the function is going to be increasing. I can do it that way. I could also pick a test point like 0 and plug it into the derivative. When I plug in 0 into the derivative, don't I get a positive number? Well, 0 minus 0 plus 10. Positive 10, right? So that means I'm increasing between negative 5/3 and 1. I can either do it using my calculator or I could do it using a test point. But the values which f is increasing are from negative 5/3 to 1, not included. They're not included because I'm at a stationary point at 1. I'm at a stationary point in negative 5/3.
So you can use the x values from the derivative, but you cannot use the y values.
Yes, you do not want to use the y values. The y values are only good for like points, and that's only with the original. So it's always the x's. So wherever the derivative is greater than 0, that's where it's increasing. Wherever it's less than 0, that's where it's decreasing. Let's take a look at this one. A little bit more lengthy. We actually have a few more parts to this. This is us on the paper too, because it incorporates a few things. Let's consider the function negative x to the 4th plus ax squared plus 5, where a is a constant. Part of the graph is shown. Write down the y-intercept of the graph. Great review question. How do you find the y-intercept?
Is it gonna be 5?
It is going to be 5 because you set x equal to 0. To find your x-intercept, you plug in 0 for x. So yes, my y-intercept is 5 or 0, comma 5. It's also the constant in standard form. Now we have to find the derivative. Do that, please. What's my derivative?
Negative 4x to the third plus 2ax.
Very good. So now that I have my derivative, it says it is known that at a point where x is equal to 2, the tangent of the graph of the function is horizontal. Tangent to the graph means what? Derivative. So the derivative is horizontal. Horizontal lines have a slope of what?
0.
So it's saying that when the derivative is 0, sorry, when x is equal to 2, the derivative is 0. So show that a is 8. Well, again, when x is 2, the derivative is 0. Because that's what it means when it's a horizontal line. This is how we show that a is 8. 2 to the third is 8 times negative 4 is negative 32. 2 times 2 is 4. Add over 32, divide by 4, and a is equal to 8. Even if we couldn't show that, we can still do C double I. Find f of 2 for me, please. What does f of 2 mean? I gotta plug 2 in to the original function. Be very careful. You see how I wrote this? That negative is like a -1 times x to the 4th. So had that been an odd power, it's a possibility that some of you guys might have gotten this wrong. Only the x is being raised to the 4th power, and then you make it negative. So I'm really hoping that's just what you guys did. Because I should have -16 plus 32 plus 5, which is 21. So that means that when x is 2, y is 21 on my original function. I know that when x is 2, oh, and that's at the horizontal. So we already know this point right here is 221. That's what that means. Because when x was 2, the tangent was horizontal, so it had to be at a turning point. More specifically, we know that point is 221. Now there are 2 other points where the graph is horizontal, and you can see it. It's here and it's here. It's asking you to write down the x coordinate of these 2 points. You can find this out by a little bit of process of elimination, or you can set the derivative after I plug in 8 for a, and I can set that equal to 0. I am going to do this without a calculator because I need you guys to remember how to do this. I can factor this out. The first thing you look for when you factor should always be your GCF. What do these 2 terms have in common? A 4 and an x. So if I factor that out, I'm left with -x squared plus 4 is equal to 0. So then I would set each of these factors equal to 0. Just refresh your memory of how to factor. When I divide both sides by 4, x is equal to 0. That's one of them. Here, if I add over x squared and then take the square root, I'll get x is equal to what? 2. I already know that x is equal +2, so my other 2x coordinates are 0 and -2. Again, I just wanted to review factoring with you guys for that one. You could have easily plugged a back into the original, graphed it, and found those maximum and minimum points. Now it's asking you the intervals where the gradient of the graph is positive. Gradient of the graph means what? derivative. They just flipped and said gradient. That means slope. The slope of the graph is positive, AKA the derivative, the tangent line. So I'm looking where the graph is positive, AKA where the graph is going in which direction?
Up.
It's going up here, and it's going up here. What are those intervals? What's that left blue interval?
Negative infinity to -2.
Very good. And
0 and 2.
very good. You could also write this as x is less than -2, and you could have written this as 0 is less than x is less than 2. You have interval notation, and then you have a variation of set notation. Last part of derivatives was optimization. This is where we had our word problems. My steps to you were to make a diagram. There wasn't one. A lot of times though with you guys always had a diagram, but if it didn't, make one. Then you need to make a formula. Depending on what it was asking you to maximize or minimize, you had to use a formula. That could be the area of a rectangle, area of a triangle, volume of a cylinder. Whatever it was asking you to maximize or minimize, you had to make a formula based off of that. Then you set the first derivative equals 0 to help you find the maximum or minimum, okay? So those were the shortened version of all those steps from optimization. And so I'm just going to use the next two examples to kind of talk you through optimization a little bit. Here's one pulled from an old exam. And it was actually like the A, B, and C of a question, because this actually went all the way to G. So this was a paper 2 question. Violetta plans to grow flowers in a rectangular plot. She places a fence to mark out the perimeter of the plot and uses 200 meters of fencing. The length of the plot is X meters. What does fencing mean? The perimeter.
Lockdown, lockdown.
So since we know that fencing means perimeter, that means that when we add up all of our sides, it should equal how much? 200. So that means X, X, and then some unknown width should equal 200. So how do we show that the width is going to be 100 minus X? Well, that becomes 2X plus 2W equals 200. And if I continue to solve for the width, it's exactly how we get 100 minus X. A lot of the optimization problems with IB, like they kind of walk you through step by step how to get to the equation, because they provided a picture, and now it's asking you to write down the area of the plot in terms of X. Area of a rectangle is what? Length times width. Well, I know my length is X and my width is 100 minus X. So I can either leave it like this, or I could actually distribute to get 100X minus X squared. I suggest distributing because, as you can see, it says Violetta places the fence so that the area is to be maximized. This is an optimization problem, which means that in order to find the value of X that maximizes the area, I'm going to need to take the derivative. So you want the most simplified version of the area equation. So what's the derivative of the area equation? Negative 2X plus 100. If I set that equal to 0, I'll get negative 2X is equal to negative 100. So X is going to be equal to what? 50. 50 is going to be what maximizes it, but you can always check. On a number line, if I plug in a test point, such as 40 and 60, if I plug them into the derivative, that gives me negative 80 plus 100, which is a positive number, and then negative 120 plus 100, which gives me a negative number. If I go from positive to negative, that is indeed a maximum, okay? If you were to get two solutions, you definitely want to check to make sure one of them is the one that gives you the maximum, not the minimum. But this is an optimization problem pulled straight from an old IB exam. Some problems we won't always have to create the equation like we did here. Sometimes they'll be given to us. And so for our last example, here's one right here. It says a food company produces ice creams in the shape of a cone with the hemisphere on top. It should be a cone, not Coke. Each ice cream consists of a cone base with a height h and a radius of r. Hemisphere on top of the cone's base, also with the radius of r. The total surface area of the ice cream cone in centimeters squared is given by the formula. They gave you a formula already. We didn't have to create it. We take that as a blessing. The ice cream designers of the company have been instructed to minimize the surface area of the cone in order to reduce the melting rate of the ice cream. This is an optimization problem. I'm minimizing surface area. This formula they gave me was the equation for area. So of course they're going to ask me to find dA over dr, AKA the what? Derivative. And in a part B, it asked me to calculate the value of r that minimizes the total surface area, which means I'm going to have to do what in part B? Set the derivative equal to 0 and find which one gives me the minimum. Do this problem in its entirety. So what is dA over dr?
4 pi r minus 60 pi over r squared.
Anybody not get this? So then you set this equal to 0. And you solve. I suggest doing this algebraically by adding over the 60 pi over r squared, multiplying both sides by r squared, dividing both sides by 4 pi. When you divide 60 pi by 4 pi, what happens to the pi's?
Cancel.
And what's 60 over 4?
15.
Yep. And then I have to do what to get r by itself?
Cube root.
Cube root.
Where's cube root located in the calculator? Math, option 4. So then I type in 15, and when I round up the 3 significant figures, I get 2.47. So 2.47 centimeters is my radius that's going to minimize my total surface area. How can I be sure that's the minimum? Well, that's the only value that I get, but I can also make a number line, pick some test points and plug in. Like 2 and 3. All right.
Can you also put the graph of the derivative?
It gives you an answer, but it's just a straight line. It's not like the actual thing.
But the one thing that you can, you said it gives you a straight line.
Yeah, if
It's
it's in the
not-
bottom, it's negative, if it's on the top, it's positive.
Exactly.
So it tells you, like,
Exactly. So you can do that. So if this is the graph of the derivative, this is dA over dr, then you know that you're going from negative to 0 to positive on the derivative. So then that would be indicative of a minimum. And that was derivatives. I think we originally spent about 3 weeks doing derivatives, summed it up in about an hour. Okay.